Okay, so here I'm going to go through another problem, really from the beginning, the start of the process, the problem-solving process, right through just writing the program. So you could see what the full process looks like in the second example. So here's the problem. 1 acre of land is equivalent to 43,560 square feet. Write a program that calculates the number of acres in a tract of land with 389,767 square feet. Display the number of acres and the number of square feet. So we want to think about the whole problem. You know, start to think about the variables we're going to need, start to think about the calculations, start to think about what our test data is going to look like. And so again, I'm going to use the program design document in order to do that. So in this program that I'm looking at here, this problem, I am going to need to store the number of acres used, right? In this specific problem, it's, this number here. Now, maybe if we ran the program for a different number of acres, the number could be different. So that's really a variable. And then we're trying to determine the number of square feet. So we're going to be using variables for those two things. And then initially our square feet is going to be 389,767. So I'm going to store that in that variable. Now, in this chapter, we're only talking about assignment statements. In chapter 3, we'll begin to have the users. The user of the program enter in information, so they might be able to enter in the information later on, but we're just not there in chapter 2 yet. So we're just going to assign the value into that. So here's our algorithm. All right, now I'm just as a review here, I'm going to bring you back to this is the lecture and assignment folder in chapter 1, and there were several videos in here, oops, sorry about that, on algorithms. Based on the answer on the quiz question regarding the algorithm, I would say almost everybody should go back and watch at least these 3 videos again. Okay, we want to have some process for our algorithms. So what I'm going to recommend in our design document is kind of like this outline format, because really there's 3 things that you do in every simple program. You get some information, you perform some calculations, and you display some results. So if you follow this format with your algorithm all the time, that's probably best. And then the other thing is, with our algorithm, we want to use these variables, okay, that we're talking about here, because eventually this is going to turn into our program. So a lot of times your algorithm might look a little C++-ish. It might look a little bit like assignment statements sometimes, and that's okay. So in this problem, we're getting the information is going to be, we need to know the number of square feet that are, are here, right? How many square feet do they have? We want to figure out the number of acres, which is going to be the square feet divided by 4,356, right? Because 1 acre is equivalent to that many square feet. And then it tells us to display both the number of acres and the number of square feet. So those are the 2 things that are going to display. Notice how I'm using these names consistently, these variable names, okay? And then we always have to have some test data, because we need to know what number is expected when we run our program. So for this problem, this is how many square feet we have. This is how many square feet are in an acre. So 8.95 is what we should get when we run our program. If we don't get 8.95, there's a problem somewhere and we have to figure out what it is. Okay. So here's the full program design document. The only thing that, in this chapter we introduce constants. So if you wanted to use a constant to solve this problem, you really could. And I'll just show you, okay. So maybe, our square feet per acre. And when we declare our constants, we have to give them a value. So I'll just put this value in here, which is 43560. And then we could use square feet per acre here if we want. So because we did talk about constants, that's something that would fit into this program if you chose to do that. So just think about constants being something that's not going to change. The number of square feet per acre is not going to change. That number is always going to be 43,560. Okay. All right, so we're going to take this information to our code. We know what the test data looks like now. And just as a reminder, I'll bring you through the whole process, right? File, new, project. All right, I'll give this, well, what is this? Oh, this is going to be project. You can have your file, your project name be the same as you want as your file name. Or it could be something different. That's up to you. So let's see. Maybe I'll just call it project 2. I'm going to put this on my desktop so I can find it. Make sure that's not checked. Say OK. Okay, and now I'm going to add my new item. You'll see when I give you the project instructions, I ask you to call it last name 2, so I'll call this guy Sorrentino 2. Well, this isn't a project, right? I'll just call this I'll call it acres. There we go. All right, so over here, now we have our source file, right? That's the name of our tab, and this is where we start with our program. Oh, there we go. Look how quick that was. Okay, so you include IOStream, using namespace standard, the main program, system pause, return 0 at the end. We know all that. All right, so here I've declared a constant double, square feet per acre, 2 double variables, number of acres and square feet. I've assigned the square feet to be 389,767. Here's my calculation of number of acres, right? The number of acres is the square feet divided by the square foot per acre. And then I output both the square feet and the number of acres. So when I run this, this many square feet is 8.94782 acres. Okay, that's actually the correct answer. I rounded it up in my test data. If we don't format our double variables, you'll generally get 5 places after the decimal point. Sometimes if you only see 2 after that, it might be because it was a repeating number, like 0.166666 might show up as 0.17. In Chapter 3, we'll be learning how to format that so it looks a little bit better. But I am getting the result of my test data, which is what you have to look for. If I'm beginning programming students, it runs, some number comes out, we're like, hey, that's great. No, you have to check it and see. Okay, so there's kind of the full process from here's the problem to completing our design document and getting the program to run. The only thing that I'm going to say, just the problem part is easy because I give you that. So when I give you a project, I tell you what the problem is. So that part's easy to put in the design document. For the project, you'll be given a blank one of these to fill in, and that will be part of your grade.